Take a close look at these two black aluminum blocks. They look almost identical, but their surface finishes are intended to meet very different performance requirements. One uses standard Type 2 anodizing. The other uses Type 3 hardcoat anodizing, which is commonly specified for demanding industrial and aerospace applications. Choose the wrong process, and you may end up with inadequate performance or pay for a level of protection your application doesn't require. Unlike paint, anodizing isn't simply a coating applied over the metal surface. It is an electrochemical process that converts the aluminum surface into a controlled layer of aluminum oxide. Bare aluminum is relatively soft and susceptible to scratches, wear, and corrosion in harsh environments. Anodizing can improve corrosion resistance, provide a degree of electrical insulation, help reduce galling, and create a harder, more durable surface. The key difference lies in the processing conditions used to form the oxide layer. Type 2 is typically processed in a sulfuric acid electrolyte near room temperature. The resulting oxide layer is typically 5 to 25 microns thick. Type 3 uses a chilled electrolyte in a higher current density under tightly controlled conditions, producing a thicker, denser oxide layer, typically 25 to 75 microns thick, depending on the applicable specification and application. Type 2 is well suited for decorative finishes and offers a broader range of color options. Type 3 is designed primarily for hardness and wear resistance. First, we'll try a light scratch. The Type 2 surface shows a visible mark, while the Type 3 hardcoat shows little to no visible marking. Under a much higher point load, however, both surfaces can be damaged. The Type 2 coating is scratched more deeply, but the Type 3 hardcoat also shows a visible mark. This behavior is often described as the eggshell effect. Although the oxide layer is extremely hard, the aluminum substrate beneath it remains comparatively soft. Under a concentrated impact, the substrate can deform, causing the hard oxide layer to crack. Hardcoat anodizing is designed primarily to improve wear resistance. It doesn't make the part immune to impact damage. The real advantage of Type 3 becomes clear under repeated sliding wear. Here, both parts are subjected to the same abrasive medium and the same number of back and forth cycles. The Type 2 anodized layer has worn through, exposing the bare aluminum substrate. The Type 3 surface shows only light scuffing, while much more of the protective hardcoat remains intact. This is why hardcoat anodizing is widely used on mechanical components subject to repeated sliding, rubbing, or contact. So, which one should you choose? Choose Type 2 when appearance, color options, and cost effectiveness are the main priorities, especially for consumer products, housings, panels, and general purpose parts. Choose Type 3 when the part must withstand repeated sliding, abrasive wear, metal-to-metal contact, or harsh industrial environments. But keep in mind that a thicker anodized layer can affect hole diameters, thread dimensions, fits, edge conditions, and surface roughness. The finish should be accounted for during design, before critical dimensions are finalized, not selected after the part has been manufactured. Need help selecting the right finish for your part? Reach out to us today. Our engineers are ready to work with you on the perfect solution.